Welcome to Vision Plus and welcome back to S.4 Mathematics. We are now doing the last example under normals and tangents to curves. Example 5 says, find the equation of the tangent and the normal to the curve. Part A, the curve is given as y equals to 5x cubed minus 7x squared plus 3x plus 1 at the point 1 and 3. This is the point of tangency, which is a common point to the tangent, to the curve, and to the normal. So, to find the equation of the tangent, we need the gradient of the tangent. The gradient of the tangent is the same as the gradient of the normal, is the same as the gradient of the curve at the point of tangency. The gradient of the tangent will never be the same as the gradient of the normal, okay, at the same point of tangency. So, sorry about that. Now, we need to find the gradient of the curve, which means we need the gradient function. So we differentiate the equation of the curve. Therefore, dy dx becomes 15x squared minus 14x plus 3. This is the gradient function of the curve. And this is a function that defines for us the gradient of the curve at any point on the curve. Now, we have a point, which is the point of tangency. Therefore, the gradient of the curve at the point of tangency 1 and 3 becomes, this is x, this is y. We substitute for x in the expression for the gradient function. So here we shall have 15, 1 squared minus 14 times 1 plus 3. Then you press the calculator. It's like 4. 15 times 1 squared is 15. 15 minus 14 plus 3 is 4. So 4 is the gradient of the curve at the point of tangency. And we know that at the point of tangency, the gradient 4 of the curve is the same as the gradient of the tangent. Therefore, this is also the gradient of the tangent. Now, when we know the gradient of the tangent and one point on the tangent, then we can find the equation of the tangent, simply because the tangent is a line. Equation of the tangent. So we have m, which is the gradient of the tangent, m is 4, and then we have the point on the tangent, which is 1 and 3. So we can say y equals mx plus c, because the tangent is a line. So this is x, this is y. Substitute, that means 3 equals to m is 4 minus x is 1 plus c. When you make c the subject of the formula, c is negative 1, and c stands for the y-intercept. After getting c, then you come and substitute for m and c to get the equation of the tangent. Therefore, the equation of the tangent becomes y equals to m is 4 x plus c, but c is negative 1, so minus 1, and that is the equation of the tangent to the curve at the point of tangency 1 and 3. In the same manner, we go to the equation of the normal. We know that the normal is perpendicular to the tangent. That guides us a lot. The normal is perpendicular to the tangent. That means they are perpendicular lines. What do we know about perpendicular lines? The product of the gradients of two perpendicular lines is negative 1. Therefore, the gradient of the first line n1 times the gradient of the second line n2 gives us a negative 1. So let me call the gradient of the tangent m1. So substituting for m1, you have 4 times m2 equals to -1. Therefore, m2 equals to -1 out of 4, where m2 is the gradient of the normal. Since we have the gradient of the normal and one point through which the normal passes, remember this point is for all, that is the curve, the tangent, and the normal. So if we know one point through which the normal passes, we can find the equation of the normal. So we have the point 1, 3, and then we have m, which is the gradient of the normal. The normal is a line, therefore it is given by y equals mx plus c. And we know that c is the y-intercept. Go to Senior 2 and revise coordinate geometry. So this is x, this is y. We substitute to get c. So 3 equals to m is -1 out of 2 times x is 1 plus c. That means our c becomes 1 divided by 4 plus 3, 13 out of 4. 13 out of 4. When you make c the subject of the formula, you get 13 out of 4. Yes. Now after getting c, and then we come and substitute for m and c. Therefore, the equation of the normal, which is a line, becomes y equals to -1 out of 4. That is the gradient x plus c. C is 13 out of 4. So this is the equation of the normal in part A, and that is the solution to part A.